We move on to the next one, channel types. Four channel types are recognized in the SSH connection protocol specification. Let's see one by one. Session, the remote execution of a program. Session is nothing but the remote execution of a program. The program may be a shell, an application such a file transfer or email, a system command, or some built-in subsystems. Once a session is opened, a subsequent request are used to start the remote program. Second one, X level. This refers to the X window system, a computer software system and a network protocol that provides a graphical user interface GUI for networked computers. X allows applications to run on a network server but to be displayed on a desktop machine. Third one, forwarded TCP IP. This is a remote port forwarding. We will see this in the last topic of this particular video. The next one, direct TCP IP. This is a local port forwarding. We will see this remote forwarding and local port forwarding in the port forwarding topic. Let me discuss later in this video. These are the four types of channels which is going to be get present in the SSH connection protocol specification as session, X11, forwarded TCP IP and direct TCP IP. Let us see about port forwarding. What actually the port forwarding? One of the most useful features of SSH is port forwarding. In essence, port forwarding provides the ability to convert an insecure TCP connection into a secure SSH connection, which is going to convert an insecure TCP connections into a secure SSH connection. This is going to be called as port forwarding. This is also referred to an SSH tunneling. We need to know that what a port is in this context. A port is an identifier of a user of TCP. We need to know the application that run on the top of TCP has a port number. The incoming TCP traffic is delivered to the appropriate application on the basis of the port number. An application may employ multiple port numbers. For example, for the simple mail transfer protocol, the server side generally listen on port 25. So an incoming SMTP request uses TCP and addresses the data to designation port as 25. The TCP recognizes that this is the SMTP server address and routes the data to the SMTP server application. Let us discuss about the particular port forwarding. The port forwarding supports two types. One is local forwarding and second is going to be remote forwarding. Let us discuss about one by one. The figure which is going to be described over here, the basic concept behind the port forwarding, we have a client application that is identified by a port number X and a server application identified by a port Y. The client is going to identify a port X and a server is going to be identified by a port Y. At the same point, the client application invokes the local TCP entity and requests a connection to the remote server on port Y. The local TCP, the connection which is going to be requested, the local TCP entity negotiates a TCP connection with the remote TCP entity such that the connections links local port X to the port Y. To secure this connection, SSH is configured so that the SSH transport layer protocol establish a TCP connection between the SSH client and server entities with the TCP port number A and B. Example, it's an unsecured TCP connection via a TCP. So we are going to request to create or to provide a secured entity, SSH client and server entities through a secured channel, such a way which is going to be providing an connection, a port number A and a port number B respectively. A secure SSH tunnel is established. A secure SSH tunnel is going to be established over this TCP connection. A traffic from the client at port X is redirected to the local SSH entity and travels through the tunnel where the remote SSH entity delivers the data to the server application on port Y. Traffic in this other direction is similarly redirected. So SSH supports two types of forwarding. One is called local forwarding and one more is called as remote forwarding. The local forwarding allows the client to set up a hijacker process. This will intercept selected application level traffic and redirected it from an unsecured TCP connection to a secure SSH tunnel. SSH is configured to listen on selected ports. SSH grabs all traffic using a selected port and sends it through an SSH tunnel. On the other end, the SSH server sends the information or incoming traffic to the designated port dictated by the client application. The following example should be help to clarify the local forwarding. Suppose if you have an email client on your desktop and use it to get an email from your mail server via the post office protocol POP. The assigned port number of POP3 is port 110. We can secure this traffic in such a way, in the following way. Let me explain about that. The SSH client sets up a connection to the remote server, selects an unused local port number, say 9999, and configure the SSH to accept traffic from this port designated designated for port 110 on the server. The SSH clients informs the SSH server to create a connection to the destination, in this case mail server port 110. The client takes any bit sent to the local port 9999 and sends them to the server inside the encrypted SSH connection or a session. The SSH server decrypts the incoming bits and sends the plain text to port number 110. In the other direction, the SSH server takes any bit received on port 110 and sends them inside the SSH session back to the client, who decrypts and sends them to the process connected to the port 9999. Let's discuss about the remote forwarding with an example. The user SSH client acts on the server behalf. The client server traffic with a given destination port number, places the traffic on the correct port and sends it to the destination the user chooses. A typical example of remote forwarding is, we will see the following. For example, you wish to access a server at work from your home computer. Because the work server is behind a firewall, it will not accept an SSH request from your home computer. However, from work you can set up an SSH tunnel using a remote forwarding by involving the following steps what we're going to discuss over here. From the work computer, we need to set up an SSH connection to your home computer. Then the firewall will allow this because it is a protected outgoing connection. Then we need to configure the SSH server to listen on a local port, say 22, and to deliver data across the SSH connection addressed to remote, say 2222. Then you can now go to your home computer and configure SSH to accept traffic on port 2222. Then you now have an SSH tunnel that can be used for remote logon to the work server, so that we can extract the data from the server which is going to be behind the firewall, and you can access all the data from your home computer. Such a way we can do the forwarding, port forwarding with the help of remote forwarding. So hope that we come to a conclusion of this particular module 1. In this video we have come across with an hypertext transfer protocol over an SSL, HTTP over an TLS, and a secure shell, and in that we have come across with a protocol stack, the transfer layer protocols, which identifies the packet formations in the TLP, and cryptographic algorithms, and SSH user algorithm protocols, and finally we have been ended up with the port forwarding. In that we have seen local forwarding and the remote forwarding. Hope that this video will be helpful for you guys to understand the HTTP and SSH. If you have any queries on this, kindly you can post the queries to me. Thank you for watching this video. Thank you.